Physical science is the study of non-living things. It's the ability to use logic and reasoning to explain what goes on in the world around us. It's also the study of matter and its motion and behavior through space and time, along with related concepts such as energy and force. Physics looks at how things happen, and it's the reason why things happen. We can also discover more about how stars are made and how we can generate energy and power for ourselves. Have you ever wondered what would happen if your tongue stuck onto an ice-cold frozen pole? How is sound and light energy important to our existence? And can we exist with one and not the other? How does gravity, electricity, and magnetism affect our natural world? How and why substances combine or separate to form other substances? Chemistry deals with a lot of things. We ask questions like, how can the car move? What is providing the forward motion? How are the wheels even able to turn? How high can a ball that was thrown move upwards? Why doesn't oil and water mix? Where does the white light on the stage come from when all I can see is different color lights? physics is just applying or finally using all of the tools you have accumulated throughout your education to figure out the way the world behaves. Take chances.
A good day to you, grade 10 learners. Welcome to today's physical science lesson brought to you by the Gauteng Department of Education. My name is Dabezinhle Dliwayo. I'm going to go over with you the section on today's physical science. In today's lesson, we are focusing on revising term one's work. So I hope you are ready for this lesson. I would like you to take this moment to actually test yourself. So what we're going to do in this lesson, we are going to do typical examination questions. So take a piece of paper, take your calculator, and just be ready to do the calculations together. So in term one, we actually looked at waves, sound, and light, and also we looked at electricity and magnetism. So coming into this lesson, you're supposed to be having knowledge on the concepts of waves, sound, and light. So by the end of this lesson, you should actually be able to attempt typical examination questions pertaining to waves, sound, and light, and also some examination questions on electricity and magnetism. Okay, so we're saying now your pre-knowledge is based on what we covered this term. And in this term, we said we looked at wave, sound, and light. So I hope you still remember the concepts that were actually pertaining to these topics. And also, we're saying we looked at electricity and magnetism. So this is how we're going to work throughout this lesson. Right, so I'm going to give you questions as per topic. And these questions are coming from the past examination questions. So I'll give you time to attempt the questions. So make sure that you are now ready. And I'm saying, can you test yourself? See how much you remember and how much you can score. And then we're saying, after I've given you time to tackle those questions, we're going to go over the questions together, and of which I'll give you time to write the corrections. All right. So I hope you are ready. Let's make this activity more fun because we are trying to gauge yourself how much you know, isn't it? So let's start with the first question. Right. The first question is based on waves, isn't it? And the question is in two parts. So it's 5 marks, it's worth 5 marks. So let's see how much you are able to score out of those 5 marks, isn't it? So for this particular question, I'm going to give you 5 minutes, isn't it? So I'm going to give you 5 minutes starting from now. Okay, welcome back. Welcome back. Now let's see how we actually did on that question. The first part is the define the term amplitude. Right, so check your definition there. Right, when we're talking of the amplitude, we're talking of the maximum displacement of a particle from its equilibrium position. I believe you got that right, isn't it? In reference to our diagram, remember that part there, that horizontal part, that is our rest position, isn't it? Or our equilibrium position. That is the position of our medium before we actually apply our disturbance, isn't it? And then we're saying that maximum displacement, you can consider B there. You can see B there. We're saying from the equilibrium position up to the maximum point, which we actually call our crest. Remember that top part we call our crest, isn't it? That is typically our amplitude. Or you can even take it in the opposite direction. If you're going in the negative, you've got negative P there, isn't it? So you're moving from the rest position to the trough. Remember our terms, the crest and the trough of a wave. So definitions normally they consist of 2 marks. So make sure that you know your definitions. I hope you got that one correct, isn't it? Right, let's go to the next part of your question. Now you are asked to draw the shape of the resulting wave as the two waves cross each other. So we've got wave B and wave A crossing each other. What is the resulting shape? Right. So now in order for you to answer that question, you have to remember our principle of superposition. Okay, our principle of superposition. And what does the principle state? Remember that our principle states that the resultant, the resultant amplitude that we have there is the sum of the two amplitudes. So we've got the amplitude of A and the amplitude of B. So what we have as a resultant there is the sum of the two. So you're using the principle of superposition. And now since our waves, they're actually meeting crest to crest, what we're having there, remember, it's a form of interference. And what did we call that interference? We said that is constructive interference. I hope you still remember those terms, right? And now looking at the sketch, you can see the sketch, the possible answer then, your answer should have a bigger magnitude, isn't it? Because we're having constructive interference. And also looking at your sketch should be similar to the original diagram. What do I mean by that? Count the number of cycles. If you check there, we have got one wavelength, two wavelengths, isn't it? So check your diagram as well. It means in your sketch, you're supposed to be having also two cycles, isn't it? So you have got one cycle and also two cycles. You can count the crests there. One, two crests, one, two, one, two troughs, one, two what? Troughs. Right, so that you can earn your 3 full marks. So remember there we are having constructive what? Interference. The opposite being destructive interference. I hope you were able to answer that question correctly, isn't it? Now, remember to actually be communicating with us in the WhatsApp platform, isn't it? So for now, I'll give those of us who got the question maybe wrong a minute for you to sketch the proper sketch and for you to digest the concepts, isn't it? 1 minute. Okay, welcome back, welcome back. Now let us proceed with our questions. Now we are looking at sound waves. We're looking at sound waves, and there again, I've got two questions for you. Two questions for you. Remember, have your data booklet ready with you by your side so that you can make, maybe you can actually look at some of the formulas that you may need during these calculations. Right, so let's see how much you do now on the topic of sound waves. Another typical examination question for you, and there I'm also giving you another 5 minutes starting from now. Okay, welcome back. Welcome back. I believe you've successfully tackled that question. So let's see how much you got there out of the 6 marks. Right, let's start with the first part. We have Tembi there. Tembi is beating a drum, isn't it? Right. And what we are told now is that as she beats the drum there, it's like every time she beats it, it coincides with the echo. Right. What does that communicate to us? Remember, for you to hear the echo, the sound is to travel first, okay, to a barrier there, which is your wall, isn't it? And what is going to happen? It is going to be reflected back. All right. It gets reflected back. Right. So this is the concept that you are having, the concept of reflection of the sound. Right. Now we are asked, what is the speed of the sound in air? So the first part, we need our formula. What is speed? Remember, who can tell me what is speed? Yes, remember speed is equal to distance over time. Right. Remember we said whenever you've got a formula, it is a free mark. So the moment you've got a formula, know that you have earned yourself a free mark. So check if your formula is right, isn't it? So now the question is, what is the distance? We said the sound goes first, that's the first 85 meters to the wall, and then it travels back another 85 meters. So it means the total distance that is traveled is going to be 2 times 85 meters, isn't it? And then what is the time? The time we're given there in our question is 0.5 seconds. Right. And now what is left is the job of the calculator. You can punch in there in your calculator, and I'm sure you're getting 340 meters per second. Don't forget your units. Meters per second, those are our units of speed. So when you're dealing with our echoes, remember, you look at the distance that is traveled to and fro. I hope you really got that one correct. If you did, those are your 3 free marks. And you can take note where you might have gone wrong, isn't it? So the important thing there is our formula, distance over time. I hope it makes sense, isn't it? Because for us to hear our echo, we're saying the sound has to go to your barrier and then it is reflected back, right? You can go over your concepts on sound, and remember, it's all about that 0.1 second time delay. As long as the delay is above 0.1 seconds, you can hear that echo, isn't it? Right. I hope you can see where you might have gone wrong in that calculation. And those of us who got it right, feel free also to send it on our WhatsApp platform so that we can actually celebrate together, isn't it? Right. Let us proceed to the next aspect of our question. Right. The next part, you are asked to calculate the wavelength of the sound wave. You are given the frequency there is 100 hertz. Right. Important thing again is the formula. Remember I said if you have the formula, it's as good as a free mark. So what is the formula that you are supposed to use to get our wavelength? Right. Okay. Remember our formula, speed is equal to wavelength multiplied by frequency. Right. Speed is equal to wavelength multiplied by the frequency. I believe you've got that formula with you, isn't it? You can take it down. What is our speed? The speed is the one which we calculated in the first part. Remember, we've got such questions in the examination. One question, the answer for the first part, you use it to tackle the question in the second part. And what is our speed? We say it is 340. Right. 340 meters per second, and the wavelength is the one we want to calculate, isn't it? And what is our frequency? Our frequency there is given as 100 hertz. Now you can make the wavelength there the subject. What is our wavelength? Wavelength is 340 divided by by 100, isn't it? And what are we going to get? 3,4 meters. That would be the wavelength of our sound wave. Right. So I should stress again the importance of our formulae. Master the formula and your work will be very, very, very easy. Isn't it? So I hope you can see where you might have gone wrong or where you might have gone right. I hope there is those of us who actually managed to get 6 out of 6, and those who might have got it wrong, still fine. So you can make corrections where you might have gone wrong. I hope it makes sense, isn't it? I hope it makes sense. Now, still on sound. I've got more questions now on sound. Let's take a look at the following question. All right, let's take a look at the following question. For this question is actually dealing with ultrasound. Ultrasound. All right, try to remember what ultrasound is all about, its applications, and so on. So for this question, I'm going to give you 4 minutes. All right, 4 minutes. So 4 minutes starting from now. Okay, welcome back. Welcome back. I hope you were able to tackle this question. Just to mention, to Tolore High School, thank you for your participation. Guys, can you keep on your solutions coming, your concerns through our WhatsApp platform so that we may actually assist each other, isn't it? Right, we're still on the concept of sound, and then here we are talking about ultrasound. What is meant by ultra ultrasound? Remember, ultrasound actually refers to the sound which has got a frequency of 20 kilohertz to about 100 kilohertz. Remember, when we're talking about kilohertz, we're talking of 1,000, isn't it? So we're talking of 20,000 hertz to 100,000 hertz. And remember, this frequency is above the hearing frequency of a human ear. Humans cannot hear any sound above that frequency. And also remember, when we talk of the frequencies below 20 hertz, we call them what, by the way? I can see some of you have actually got it right. Yes, we call them infra what? Infrasound, isn't it? So humans cannot hear within that range. Right, now give one non-medical use. It's very important to take note of that. They didn't ask for a medical use, but it's a non-medical use. So number one, we have for determining the thickness of metals and plastics, and also for detecting invisible cracks in the wings of aircrafts, isn't it? Those are some of the applications that you can mention that are non-medical. But in relation to your examinations, it is also important that you master the medical applications. Remember the ones that we use for scanning, like pregnant women, isn't it? To monitor the growth and development of unborn unborn babies, isn't it? And of importance again is how is that ultrasound scan produced? Okay, normally in some examination questions, you are expected to be able to highlight the steps, okay, to the production of that ultrasound image. So you can take that down as a point of view to research how is an ultrasound scan developed. List down the steps, okay. Then the next part, why is ultrasound often preferred to other types of body scanning? We're talking of other types like X-ray scanning, isn't it? Why is it preferred? The first part, ultrasound is safe, right? Can you take it down? Eh? Ultrasound is safe. Why is it safe? We're saying it has no ionizing radiation. Remember, when we're talking of ionizing, is the formation of ions, isn't it? Generation of ions. Why do they come about? If you are using high frequency radiations, they've got a lot of energy that can actually ionize your cells or tissues, leading to tissue damage. So in that regard, our ultrasound is very, very safe. That is why it is even used to on pregnant women. It can be exposed to those pregnant women. The other point is that your ultrasound can actually generate better pictures for soft tissues compared to X-rays, isn't it? So it gives actually very clear pictures, okay, compared to other scanning methods. Right, I hope you were able to get those points. This is the section on our sound waves. We covered a lot pertaining to sound waves, but in relation to this question, we're going to end there, isn't it? So for the sound waves now, I'm just going to give you about 30 seconds for you just to update certain sections that you may have gone wrong. Just 30 seconds. Okay, welcome back. I hope you were able to take down the necessary points. Right, let's continue with our revision. I hope you are finding it exciting and lively, isn't it? This is meant for you to actually gauge yourself. Can you gauge yourself how much content you still remember on the sections that we covered this term? Right, let's go to the next section, electromagnetic radiation. Right, for electromagnetic radiation, there I've got two questions. Those are just two short questions, isn't it, on electromagnetic radiation. So I'm going to give you 2 minutes. 1 minute, 1 minute for each, isn't it? So 2 minutes for that question, starting from now. Okay, welcome back, welcome back. Let's go over those sections on electromagnetic radiation. So we're looking at wave particle duality. What does this mean? Right, it actually means that your wave has got both characteristics, those characteristics of a wave and also the characteristics of particles. Simple and what? And straightforward. I want you to understand something. It is not that at one stage it behaves like a wave, at one stage it behaves like a particle. Understand that it has both these qualities or these characteristics at the same time. So get that correct. It has both the characteristics of waves and characteristics of particles. It has these natures, but we can actually observe them individually through different experiments. Right, an exciting field of study there on quantum physics. You'll learn about it more in your grade 11, isn't it? But that is the direct and precise answer that we want. It has got both the characteristics of a wave and the characteristic of particles. Right, I hope you got that right. Now, you're supposed to arrange the electromagnetic radiations there in order of decreasing wavelength. Right, let's see how you manage to order them. Right, so we are starting with the infra, going to visible, going to X-ray, going to gamma. So we're decreasing, meaning that the infrared has got the biggest wavelength and the gamma, the smallest what wavelength. So we're looking at low frequency going to the high frequency. I hope you got that right, isn't it? For such questions, you should develop skills to remember the order, isn't it? Um, Right, let me give you a simple way how you can remember them. Listen to my words and you take them down as I speak. So let your pen be ready, pen and paper be ready. Ne? Can you take down the words that I'm saying. Okay, can you write retabile? Retabile's mother is visiting Uncle Kolo, Uncle Kolo's guardian. Can you master that? I said Retabile's mother is visiting Uncle Kolo's guardian. Right. That is a way you can remember your waves, isn't it? The first, the first one, the R is the radio waves, M is the microwaves, I is your infrared, V. Okay, so we're saying that is the order, isn't it? Retabile's mother is visiting, which is your visible light, uncle. Okay, so and so on, isn't it? That is the ultraviolet. Then you go to the X-ray and the gamma rays. So now that is the way you can actually remember your whole electromagnetic spectrum. I hope you got that one down, isn't it? So you are going from the biggest wavelength to the shortest wavelength there, isn't it? Retabile's mother is visiting Uncle Golo's guardian. I think that is easy to remember, isn't it? Right. Let us proceed. Next question. For this question, we will answer it this way. Let's start with the definition of a photon. Is it? For the definition of a photon, there, I'll give you 1 minute. 1 minute for you to grind your mind and remember the definition. 1 minute. Okay, welcome back. Welcome back. Our definition of a photon, a particle of light energy. I believe that you got right. Or you can say a quantum. A quantum of light energy is still acceptable, isn't it? Remember wave particle duality. Think of the photon. Right, guys. Can you please communicate with our WhatsApp platform? We want to see if we're making progress. Are we moving together? Okay, so keep on. Your answers, can they come? Your concerns, can they come? Right. This next question, we're going to do it in parts. The first part, I'll give you 2 minutes. Okay, I'll give you 2 minutes. I haven't yet said start writing. I'll give you 2 minutes to work on it alone. Then I'll ask you to stop so that I see how much you're going in the right direction, in the proper direction. Then I'll give you a hint. I'll guide you as to the steps that you have to follow, and then I give you time again. You complete it, and we finish the work together, isn't it? So in this question, as I said, I want to give you guys 2 minutes. You see, it's worth 6 marks. It's worth a lot. So I need you to follow a certain direction that you believe you're supposed to be following. Remember, establish the appropriate equation, okay? And then follow the steps. So I'm giving you 2 minutes for now. Then we work on it together. 2 minutes. Okay, welcome back, guys, welcome back. Remember, I said if it is a calculation, it is 3 marks. So these are 6 3 marks. Why is it so? Because we're saying whatever is a calculation is a formula, right? So let's go over the question together. I want you to be following and seeing where you have been going and see whether you are in the right direction, right? So we have an electromagnetic wave with a wavelength there which is given, isn't it? And you need to calculate the energy. That is the important thing. So what you ask yourself, what is my formula to get the energy of a photon? What is the formula? I know somebody has the formula. E is equal to what? H F. Remember the formula, isn't it? And what is H? H, remember, is what we call the Planck's constant. Right, Planck's constant. You remember Planck's constant? What is the value? 6,63 times 10 to the power negative 34 joule second. I believe that is there in your data booklet. Remember the Planck's constant, isn't it? And F is the frequency. This is the formula you should be having to calculate energy, isn't it? Then you look at the data that you're given in your question. Are you given the frequency? No, you're actually given the wavelength. So you ask yourself, how can I then get the frequency if I'm given the wavelength? So you ask yourself, which formula now, which equation am I supposed to use? Okay, then you say, I'm supposed to use the wave equation, isn't it? Speed is equal to wavelength times frequency, isn't it? Now you can make frequency the subject because you are given the wavelength there. And what is the speed? Remember the speed of electromagnetic waves, we call it c, isn't it? The speed of light. And we're saying this is 3 times 10 to the power 8 meters per second. This is the information that you are supposed to be having, right? So in case maybe you're lost or you're heading in the wrong direction, or if you are in the right direction, it's still fine. Now let us proceed together. So the first step, we said we want to get F, our frequency, and we said what is the formula we are using? We're using C, which is the speed, is equal to frequency times wavelength. Can you take down that formula in case you were already in the wrong direction? Right. The next thing, we're substituting in the formula. What is C? 3 times 10 to the power 8. And we need F, isn't it? And your wavelength is given there as 2 times 2,5 times 10 to the power 9 meters. Right? Just 10 seconds for you to complete that calculation there so that you can get F. Just 10 seconds. What value for F are you getting there? What value? Right? I believe we're done with getting the value for F there, isn't it? What is the value? We're getting F is equal to 1,2 times 10 to the power 17 hertz. I believe we got that, all of us. Okay. Right, now we've got the frequency. Remember our equation, the most important there to get energy. E is equal to HF, H being our Planck's constant. Remember Planck's constant, isn't it? Now we've got the frequency and we've got our H, isn't it? Let's substitute. Let's substitute the H 6,6 times 10 to the power negative 34 joule seconds, and our 1,2 times 10 to the power 17 hertz. That's our frequency. I hope you are following, guys. I hope you're following. Can you punch in your calculator? What value are you getting there for your energy? Punch those values. Punch those values. Right. I believe we are all getting 7,96 times 10 to the power negative 17 joules. Right. That's how you're supposed to attack that question. And that's why I was saying these should be 6 free marks. Wherever there is a formula, it is a free mark. That is our slogan for term 1. That is our slogan. So if you are expected to get energy, First step, we said calculate the frequency. Actually, identify the formula for calculating your energy. Look at the data given in the question, look at what is not there, and then identify the next suitable formula to get what is not there, isn't it? In this case, we needed the frequency, and then you punch in your calculator and you get your answer. The units are joules. I hope we are now able to get those 6 marks if we meet them in a typical examination question in future. Right. I hope we're still alive. Eh? I hope we're still alive and kicking. Okay, alive and kicking. Now we need to go to the next concept on what we covered in our term 1. Right. What else did we cover? Electrostatics. Remember, the study of the forces that exist between electric charges that are at rest. I hope you still remember the concepts there. Right, so now for the first part of our question there on electrostatics, just stating the principle and also the transfer of electrons. Guys, there I'm going to give you 2 minutes, okay? 1 minute, 1 minute for part 1, and for part 2, a minute each, starting from now. So we are getting 2 minutes for this question. Okay, welcome back, guys. Electrostatics, the principle of conservation of charge. Right, the principle talks about that the net charge, this is a key word there, the net charge in an isolated system remains constant during any physical change. I hope you got that one right. Take note of the key items in your definition there. The net charge. Maybe I can explain there what we mean by net charge. The net charge is actually the sum of the charges of your, in this case, it's the two metal spheres, right? If you were asked, let's say, to get their net charge, it's just their sum. Okay, you see those charges are given in nanocoulombs, the small n meaning nanocoulombs. Remember, nanocoulombs is 10 to the power negative 9. So if you wanted the net charge, you're just adding plus 4,4 plus minus 2, isn't it? And we're saying these are nanocoulombs, right? And you get something like plus 2,4 nanocoulombs. That is the net charge. And we're saying that charge, if you are in an isolated system, it means it's a system that is actually divorced, or it has no interference from the external settings. It is not influenced by an external environment. In other words, it is a closed system. So that charge remains plus 2,4. Right. That is why now we come to the concept of, if you bring A and B together, if they contact each other, isn't it? We have the transfer of charge, which is now our part 2, isn't it? Right. We'll explain further there. So, which sphere loses electrons? I hope you got that right. Sphere B. Remember, electrons, they will move from the more negative to the less negative. Right, so in this case, a negative charge actually represents an excess of electrons. So they will move from the negative to the positive, which is from your B to your A. Right, now we're saying, even if there is that movement that happens, that net charge plus 2,4 will still remain as 2,4. So if you bring them into contact, the electrons will move from B to A. Now, if you take them apart, what is going to happen? This net charge, you see that net charge, is going to be shared equally between the two, because these metal spheres, they are identical. So what will happen when you bring them apart? That is why now we're going to divide the plus 2,4 divided by 2. And remember, this leads us to that equation. If you remember that equation, Q1 plus Q2 over 2. That is where it is coming from. First, you are adding them together, and then you divide by 2 to get the charge after contact. Okay, guys, now I'll give you a minute to take down those points and also to digest those points. 1 minute.
Attitude of gratitude. What does that mean? An attitude of gratitude is the quality of being thankful. It's the quality of giving thanks. Ubonga, ulebuha. It's to be grateful. You and I have so much to be grateful for. You and I have parents who make sacrifices day and night for us to be at school. You and I have people who believe in us when we don't believe in ourselves, who love us when we don't love ourselves, who invest in us day and time again. Whether it's a teacher, it's a principal, it's a driver, it's a guardian, we have so much to be grateful for. And so I challenge you, young person, be thankful. Ubongi, lebuha. Be grateful each and every single day of your life. Strive to display an attitude of gratitude.
It's unfortunate, all good things have to come to an end. The lesson has been so interesting. Unfortunately, our time, has now disappeared. Anyway, what we have covered today, we looked at the very important equation, the wave equation, where we are saying the speed of a wave is the product of your wavelength and the product of your frequency. Remember this wave equation and how we applied it in our calculations. And we also looked at that ultrasound is our sound wave, which is between 20 kilohertz and 100 kilohertz. We also learned about electromagnetic waves, that they have a wave particle duality. We also mentioned that the energy of a photon is equal to H standing for your Planck's constant, and F, which is your frequency. These are amongst the major things that we learned about. Otherwise, we learned so many things in today's lesson, and it's unfortunate that our time is actually gone, isn't it? So we also looked at the net charge of an isolated system. We said it remains constant during any physical change. Remember the principle of conservation of charge. Right, that being said, I would like to wish you a very good day and enjoy your studies, and may God bless you.